All right, welcome everybody. My name is Shelley Benhoff, and this is the Docker Orlando online event. We are here today to talk about how Docker has changed the way we manage IT, featuring my friend, David Clinton. He is a solutions architect, Pluralsight author, and or if you would like, you can call him Your Majesty, which I love because I always have on a tiara. That's my personal brand. So just a couple announcements before we get started. I do have codes for swag that I will be handing out at the end of this event for 5 lucky people. And there aren't a lot of people in here, so your, chances of winning are good. I'll do that, yes, at the end. Yes, thank you, Preduma. Sorry. Yeah, and then the last thing is that Docker asked me to take a picture at the end. So yeah, I will be hopefully having everybody turn on, uh, their camera and take a fun picture, but it isn't required, of course. It's just something fun to do. Anyway, that's it for announcements. So without further ado, here is David.
Thank you, Shelley. I think it's going to be a lot of fun to be here. I might be a little less focused on Docker than some of you day to day. I don't do a lot of Docker work day to day in my regular activities, but I go back a long way with container technologies and with Docker, and I'm going to focus here not so much on the how stuff gets done. How do you make sure your networks are opening up what's supposed to be open and closing what's supposed to be closed, and how do you can access your volumes, your storage volumes. That's very important, of course, and it's something that anybody working with Docker has to spend time on. But I'm going to focus more on the why. That is, what can containers do for us, and what could they do for us that we haven't thought about yet? Creativity, I've always found, is a ephemeral thing. It's you can try to think creatively and come up with new ideas for new applications, and you can think for hours. And for me, anyway, I just run around in circles most of the time. My real creativity usually comes in 5-minute bursts, and it usually comes by stepping back and taking a look at the big picture of a technology or of a problem. So the container world, it has a very big picture, and it's maybe worth it. I hope it'll be worth it for you, but it's certainly worth it for me to take a step or two back and look at the history of container technologies and virtualization as a whole. And then at the end, maybe we'll come up with something new, or we'll certainly talk about the kinds of things we might want to think about to come up with something really new and useful. So yes, we're talking about Docker and containers, but from a historical perspective. So the topics we're going to focus on are a little bit of history. I'm not going to tell you what virtualization is and does. I'm sure that's not necessary in this crowd, but a little bit of the history, how it evolved. And we'll talk about Chroot and jails and LTSP, and those of you who don't know what LTSP was and is, I'll introduce you a little bit to that. LXC and here I just recently discovered, even though I've been working with LXC, Linux containers, it stands for many years, but I just discovered that LXC is pronounced LXC, but LXD is actually pronounced LexD for some reason. The official pronunciation for the technology is LexD. Okay, we'll talk about then the primary illustration of creative applications for containers is going to be admin environments. In my particular case, I'm primarily a sysadmin. I worry about administration environments and where applications live and where administration gets done. So that's what I think about a lot. I'm going to use an illustration, a very specific illustration of an environment which was completely turned upside down by actually Docker containers. Yeah, I'm going to keep an eye on the chat, by the way, if anybody does have any questions and or observations or insults or good jokes. Anything is just fine in chat. So we'll start a little bit with even though this is not going to be groundbreaking for anybody here, but the difference between virtual machines and containers. So a virtual machine, as you can see, it requires 2 extra layers of resources. A hypervisor, which interfaces between the host operating system and anything running within the hypervisor, any VMs running within the hypervisor. There's a resource overhead for that. The hypervisor takes a certain amount of system memory and system storage. And then each guest OS, each VM running within the hypervisor. An example, by the way, of a hypervisor which we probably all use is VirtualBox, Oracle's VirtualBox. Very, very handy, very versatile, very flexible tool. It allows you to run operating systems that have nothing to do with your host operating system. That's Linux and Windows, Windows and Linux, anything in Mac OS, Mac OS and nothing. You can't run Mac OS anywhere else, but as far as I know. But the flexibility comes with the cost. It takes system resources to run a hypervisor, as I said, and it takes system resources to replicate a complete guest operating system for each virtual machine you're running. So it takes up resources. Containers, on the other hand, each container shares the kernel of the host. Excuse me. So you lose 2 layers of resources that are overhead, and you have, as a result, fast and lightweight and easy to share and easy to script and automate containers. Little operating systems, as you all know, running happily with a very, very light footprint. And of course, Docker is a container. Docker was not the first species of container that the world ever saw, but it was for a while its most popular, and it's still rolling along at full speed and with tremendous innovation happening within its ecosystem. So, but as I said, it wasn't the first. It wasn't the first type of virtualization that could be loosely described as a container. If you want to get really loose in your description or your definition of container, then you go all the way back, I believe, to the late 1970s on timeshare machines that predate just about everything. Obviously, this was Unix, and the technology was called Chroot, which stands for change root. And again, it's useful I think it's useful to think about how this worked and what it was used for, to give us, again, this big picture of how virtualization can be useful in new and innovative ways. So Chroot, effectively, you're working within a Unix system. Chroot still exists today in Linux. I guess it's in Mac OS also. What you do, these are just 2 commands that are illustrative. You can't actually run a whole Chroot with 2 commands, but you would create a location in the file system. Let's, in this case, mount/temp/dev, and you mount various resources to that directory using bind. So you would mount system resources that would allow you to run commands within that directory, independent of the host operating system. When you've mounted all the necessary resources in the directory, then you load the directory, or actually you create a new shell in the directory using the Chroot command, and you'll find yourself, the shell looks the same. I'm not going to do it, replicate it now. It's a little complicated and it's just not worth it. But you are in a shell where all the commands you run within the shell exist only in the shell and have no impact on the host operating system. The advantage, of course, is isolation, that you're not risking making a mess of your host system. You're not changing any configuration files. You're not loading up directories that shouldn't be loaded up with extraneous data. You're running something specific to that directory, that shell, and what happens there stays there. Nothing goes. We have a fairly robust level of isolation. Nothing like what you can get today in Linux systems using C groups or similar isolation tools, but it was pretty good for the 1970s. Where are you going to use Chroot? Even today, if you're running a Linux system and you lose your admin password, and if you've lost the admin password, then there's really and you're the only admin on that system, you don't have a whole lot of options. The system is pretty impenetrable unless you happen to get lucky and the password wasn't that complicated and you managed to hack it. But under most circumstances, and of course you're not the type of people who would use a weak password, you're in a lot of trouble unless you want to unmount the drive. I'm not going to go through the whole process now. Some of you have probably seen it, but you can then mount the drive on a different system, a different Linux system, and you can create a Chroot in the drive which isn't mounted. You do, I suppose, mount that drive as a Chroot, in which case you'll be able to run commands within the Chroot environment, and the command you'll run will be password to update your password, and then you simply unmount the system and run it again normally, and you'll have a fully accessible Linux system with a password. That's convenient, fun, and it's a little bit magical, and it's a lot of fun to watch people who were desperate and about to, and feeling they had no choice but to burn their machine, to somehow again have life again. Another place where you're going to use Chroot in a modern context is Linux kernel compiling. Again, when you edit the kernel directory in the file system because you want to create your own distro, you want to create a flavor of Linux that does specific and customized things, things that you might be the only one who needs, but you need that environment. So the best way to do that in many cases is by compiling your own kernel. You take the file system, the kernel file system itself, make any edits you want, and then what? Well, this little snippet, this code, which features the fake root command, is similar to Chroot. It's just called fake root, but what it does is builds a little isolated environment within your Linux system where you can import the kernel file system itself, which includes any changes you've made, and compile your own new kernel. It's completely independent and isolated from the host environments. You're not making a mess of your host, but again, you're creating a clean and new environment for a complex process, which otherwise would have been really, really complicated and messy to do. So another place where you're going to use a Chroot-like technology for very modern application. But again, this isn't a container. In which way is it not a container? Well, a container, as you know, is its own standalone operating system. You can save it, share it, move it somewhere else, run it, and you'll have the exact same environment anywhere. This isn't standalone. What we're doing with fake root and Chroot is not standalone. It may have some of the comparable isolation features that a container might have, but it's not a container in and of itself. We came a little closer to the container paradigm, a lot closer actually, with FreeBSD jails. The first commercial or the first enterprise servers I actually worked on a bunch of years ago, I'm not going to say how many, were actually still running FreeBSD jails. That was kind of towards the end of the FreeBSD popularity, I suppose. It's still around, the operating system. From this website screenshot, you can see that it's definitely still, the project is alive and kicking, but it's not dominant in the way that it once was. FreeBSD, by the way, is an operating system that was built on a licensed fork of Unix, I believe. And it was built long before Linux. I think it was around long before, sometime before Linux. BSD stands for, well, the first two letters are Berkeley software. Berkeley is the university in California, which was a great home of open source software development, and still is, I believe. Berkeley Software something, I'm not sure what the D stands for. FreeBSD is the operating system that came out of that lab. So a jail is pretty much like a container. It gets its own IP address, unlike Chroot, which is still living really in the shadow of its host. A jail gets its own IP address. It has greater isolation than a Chroot would have, and I believe is simply based on it's a file system that's saved to disk, so it can be copied and moved somewhere else. So you're getting a lot closer to the kind of environment that we became familiar with through Docker. A bit of I guess maybe a little step to the side. I came into virtualization originally about 15 years ago through the LTSP project. Back then, if my memory serves me, LTSP stood for Linux Thin Client Server Project. It kind of petered out when it wasn't necessary anymore. I'll explain why in a minute. And now someone has brought it back to life with a different twist, and it's now called the Linux Terminal Server Project. It's something a little different. Back then, though, the Linux Thin Client Server Project, you're probably, if you're of a certain age, you'll be familiar with a thin client. That is, in a time when hard drives were very expensive and RAM was really expensive, and you had a school or a bank or a large company where a lot of what each terminal had to do, a lot of the functions that each user sitting in front of a computer screen would have to do was repeated. It was identical to what the next person over in the next cubby or the next classroom was doing. So since there was so much overlap and repetition, and since hard drives and memory were so expensive, what a lot of systems, a lot of companies used was thin clients. So they would basically have a screen, a keyboard, sometimes a mouse if you were really lucky, and a network card that would access the network, and it would head out into the network every time you turn the computer on. When you turn the box on, you'd have to have a CPU, of course, and some memory. It would head out into the network. It would look for a network host using a technology called PXE, I believe. It's been a long time. Yes, PXE. It would run out into the network looking for a host. Using PXE, the host would provide an image. The host, wherever it was, would provide an operating system image. The client would load the image, and it would become a working operating system entirely running in local RAM. There was nothing necessarily served to any local hard drive. They didn't even actually have to be a hard drive. I did this. I created, yeah, it was a lot of fun too, I'll tell you. I was teaching in a high school, again, this is 15 years ago, a small, private, not-for-profit high school. It definitely was not-for-profit. And we didn't have enough funds for a decent computer lab that would serve all the students properly. So I created, I think the first one I created, there were 6 thin clients. None of them had a hard drive. And there was a 7th machine, I believe, that was the server. And it had the only hard drive in the system. The other 6, whenever they booted, they would look for the network host, and that was the 7th computer. And they would boot the image using LTSP. And each of them had a perfectly functioning Linux desktop with access to shared storage space, but each one according to the login account. So you'd log into your account, and you would have automatic and invisible access to specifically your files. It was easy to manage. It was loads of fun, and I could actually do nasty things to the students. If I didn't think they're behaving quite right, I would reduce the access to certain resources or rights or whatever. It was loads of fun, but it was also really, really cheap. So the thing is that it used Chroot. Basically, you were running the little bit of RAM on the thin clients was enough to load a Chroot environment on the server. So really everything was running on the server, just didn't look that way. The thing is that as like by the end of by around 2010, I suppose, hard drives were cheap enough and coming down in price weekly that this wasn't really necessary anymore. You didn't need, there was no reason to have 30 computers in a classroom without hard drives and all sharing the resources of the server. It was just overkill and entirely unnecessary. So the LTSD program kind of fell apart and fell into disuse. Now, as you can see from this screenshot of their current website, they are the terminal server project that still uses Chroot to not necessarily use the resources of the server, but to access the desktop settings and the desktop configurations. And everybody is getting a perfectly updated and synchronized experience on their desktops, even if they're, of course, using their own resources to get there. In the day, we would have called those fat clients, but somehow that's not quite as popular a description anymore. In any case, that was LTSP. It's important because it was a very creative application of the Chroot technology, and it was I don't know if there were tens of thousands of people using it, but it was an important step towards containers. Now, how do I know that? Because one of the main developers of LTSP at the time was a fellow named Stefan Graeber. And Stefan Graeber, when LTSP originally disappeared and sort of fell out of use, he moved over to the Canonical's LXC project. And that LXC containers, those are the first, I guess you could say, true modern containers. And that's the model that was used by Docker when they developed their own system. So LTSP is like a grandparent, you might say, of Docker. So let me show you, just since I have a computer, I might as well use it. I'll show you what LXC is. Again, LXC stands for Linux Container, or Linux Containers Project. And this is the LXD version of it I'm running. So it's a modern version. So let's see if I can type. The answer probably is not. So I'm going to launch a brand new container. It's going to run Linux Ubuntu 2204, but it could be any flavor of Linux pretty much, and any version of any flavor of Linux. So it's I can run really anything natively on this kernel. It happens to be an Ubuntu image system I'm using. I'll call the new container test. It's creating it from scratch. If necessary, it'll pull the image itself. I don't think it's necessary to pull the image itself right now, and it's done. Now I can log into test with a shell, and there I am. I'm in a working, living Linux machine as a container, very lightweight container. Just out of nowhere. Now, of course, you're all Docker people, right? So you're saying, yeah, big deal. I mean, we can do that with Docker exec also. That's true. You can do this with Docker exec also, but you shouldn't. Docker's not really meant to be a system you log into and mess around with. As probably you all know, Docker is meant to be scripted with Dockerfile or whatever orchestration tool you use, but it's meant to be scripted until it's time to replace it, and then you kill it and replace it. Linux, I should say, LXC containers can be scripted and can be brought up and then destroyed when no longer necessary, but they actually have a different focus. You can use them as fantastic test beds to build a container on any distribution you like, any Linux distribution, to do anything. You can build it as a web server, as a proxy server, as really an application server, anything, and you keep it alive until it's not necessary and you kill it, but you can run it as a real server. So one is not better than the other. Docker is not better than LXC, and LXC is not better than Docker, but they have different focuses, and Docker really is something that is orchestrated by scripting. So that's the end of my that's the end of that demo. As you can see from this screenshot of the LXC image library, you see two things. Number one, its host is Canonical. Canonical, as you probably know, is the supporter and developer of Ubuntu. They also have many other businesses that are all adjacent to open source software of one sort or another. They're a great patron of the open source world and have been for a long, long time. But they are the developers and supporters of the LXD and LXC projects. So they have in this particular library maybe 150 or more distributions, Linux distributions, and various versions of them, various releases of them, and various architectures, like AMD 64, ARM, as you can see. So that are all available to as LXC images to pull and run within the LXC environment. It's a fantastic tool, and it's a fantastic community. And Stefan Graeber is still very much involved with it and very much in charge. And by the way, I should add that in the trade-off when you're thinking about a new project, should this be a VM, a virtual machine using, let's say, a VirtualBox, or should it be a container? It used to be you were constrained, and sometimes the answer was obvious. Well, for instance, if I wanted to build a container or build a VM that will, within which I can launch Docker containers to experiment, then the answer always was, well, it's going to have to be a VirtualBox, because you can't launch Docker containers within an LXC container. That's not true anymore. You can actually now, I've done it, you can actually run nested Docker containers in LXC, within LXC. I don't know how many layers you can go down, but it's mind-blowing how much you can actually do with an LXC container. And yes, 100%, without a doubt, you can run Docker within LXC. You can also run LXC within LXC. I don't know why you'd want to. You can also now, another use case that VirtualBox was usually necessary for, at least we used to think it was necessary for, is if you need a GUI desktop. If you actually need to, whatever application you want to run is a desktop application, well, that's not going to work within LXC containers. Well, that was then. Now, actually, you can run GUI desktops within LXC containers. So they're lighter, faster, and just mind-blowing. I can't get over what you can do. So that's some of the wonder of LXC. Now, let's get to really, I guess, what I really wanted to talk, what inspired me to talk about this whole thing from the beginning. This screenshot is from the website of a company called Greenbone. They produce some software that one version of the software, the open source version of the software, is called OpenVAS. And OpenVAS is a vulnerability assessment and vulnerability scanning software. It's a cybersecurity software package. I have created a number of versions of a course teaching the use of OpenVAS for Pluralsight. And the first two versions of the course, one I think was from 2017, another was from 2020, I believe. Excuse me. The first two versions of the course were 30% of the course time was spent on installing the software. And that was because I would, if I remember correctly, I would install the software from the Ubuntu or Red Hat, I'm not sure which I was using at the time, from the software repositories. And then when the software was installed, I tried to start it, and it wouldn't start because there was some background the requirements that the system wasn't meeting. So I would go online and I would try to figure out what am I missing, and what do I have to install, or what do I have to change. And I would spend, while preparing the course, I would spend a few days tracking down all the bugs and beating all the bugs, and then I'd teach the installation process that I had experienced that week. The problem is that by the time I finished teaching that and published the course on Pluralsight, and people started to use the course on Pluralsight, there was a completely new set of bugs that were facing somebody who was installing. So really, it was a waste of time. The whatever it was in video, it might have been a half an hour video describing how to get around all the bugs. It was mostly useless for the students who were actually watching the course a month later. And when I did the same thing in 2020, the second version of the course, I had the same new set of problems, but the same general idea, which were also outdated by the time the course was published. When I had to do a third version of the course, about 6 months ago, I think, I discovered, and I don't know exactly when the change happened, but Greenbone, I mean, if you look through, by the way, the text on this page, that's why I have it here, under the important section, there are all these caveats that it may not work the way you expect, it may not, the contents of the package coming from your repository may not be exactly the way we expected it to be, things may go wrong. So I discovered then that they also provide, for self-preservation purposes, they provide on GitHub and on Docker Hub also a Docker container for OpenVAS, which eliminates 98% of the problems, because Docker containers, of course, are self-contained. All the system configurations and settings are all there already. Every package and every module that's necessary is there in the container. All you have to do is come to their GitHub page, copy the script, which is above this page, above the screenshot you see right here. Copy the script, look through the script before you run it, because of course, as you know, you should never copy and paste stuff off the internet and then actually run it, because you don't know what's in there. But in my experience, the script is fantastic. Run the curl command, that'll actually download the script, and then run the setup and start Greenbone Community Edition.sh script, and you're basically there. What was a 2-day process trying to troubleshoot all the bugs turned into a 5-minute process, and very relaxing too. So this is an example of a fairly innovative but absolutely fantastic application of the container system, the container mindset, I guess, that you can use a tool like Docker to build an environment that's completely portable and solve real administration problems. That's really what I wanted to draw out more than anything else with this little meeting we're having, the meetup we're having, is that there are a lot of problems in administration. Forget about application production, the application deployments, which are an important area also, but forget about that. In administration, tools that admins use, tools that a company will use internally, that can be complicated and can get in the step on their own feet, get in their own way, simply because of the layers and layers that are of resource stack that are necessary, but can be avoided with an intelligent container. So it's not just Greenbone. They do it, as I said, for self-preservation, because they were overwhelmed with bug reports and constant a stream of requests for help, pleas for help from users who are trying to get installed. I should back up a little bit. Greenbone itself has a commercial product, and that is, as far as I understand, actual physical servers. If you deploy OpenVAS or Greenbone the way they ideally want you to, you will buy one of their physical servers and they'll ship it to your server room, and you'll deploy it there. The advantages of that include that it's got if you're going to start doing scanning operations at scale, that OpenVAS is generally not used by just one person on his own household devices. Usually it's used by security professionals who are monitoring the security status of hundreds or thousands of servers. So if you're going to do that kind of scanning at that kind of scale, so it's helpful to have standalone hardware. So Greenbone sells the standalone hardware. When they send the hardware out, it's going to work. It's guaranteed to work. It's their environment. They built it themselves. However, when we want to use the OpenVAS open source version, so as we've seen, that gets complicated, and they were probably getting close to jumping out the window under the blizzard of help requests that they're receiving, and Docker was simply a fantastic alternative to that kind of customer support. Okay, as I said, this whole discussion is really about trying to open up new possibilities, to get ourselves thinking in new directions, and what other problems can Docker solve for us? What other containers or images can we build that are going to make life a lot easier for a lot of people? So that's what I had to present, and I really want to hear if anybody out there, has some other ideas, things that you've already done, or things that you're planning to do, or things that just sitting for the last half hour has made you imagine that might be possible. So now I'm going to throw it at you. Does anybody have their own input on this kind of topic? If you don't, of course, then we can have a friendly, quiet meditation session. Also, alternatively, I'm not sure. I'm accessible through those platforms, and if anybody has any ideas, you could certainly share them there, and I would try to share them back with the community in general, and with anybody who we've met up with directly here. So that's also an option.
Awesome. Thank you so much. I see some people are typing in the chat. Yep. Perduma, loving the presentation so far. So many thoughts. Totally. Yeah, I'm more of a Windows person. I'm just kind of starting with Linux containers, and I haven't touched Linux since like 1999, probably. So this was a lot of good information for me, just like the terminology and stuff like that. And then Jonathan, hey, I'm really new to all of this, but I think it's neat. It really is. If anybody here has ever watched any of my content, my podcast, whatever, I talk about Docker constantly because I love it so much. It, man, like it's changed how we manage everything. So, yeah. Alrighty. I guess I can start to hand out codes. Let me do my random number generator thing. So I can pick people. All right. Number 1 is, I am very sorry, Chukwemeka. Mecca. I'm so sorry, Peter. It also says that you are okay. Thank you very much. If you want to send me your email, then I will send you your code.
Okay, I will do that after the meeting.
Awesome. Thank you so much. Number 2, Perduma. Yay. You are a winner. And just send me your email. I'll send you the code for free swag from the Docker store. Woohoo. I love this. All right, so that's 2 down, 3 to go. 2.
If I don't win, the fix is in. There's no way this could possibly have been an honest deal.
Yes, well, luckily, all speakers get a code. So
I like that. Okay.
Yeah,
Aside from that, I haven't actually won anything since an eraser in 5th grade.
Oh my God.
English or something. I don't know. I won an eraser. So there you go. So this would be my second prize. Wow.
Awesome. Yay. All right. Number 3 is Whale, which is a great, Docker Whale. Awesome. Send me your email. If anybody, where should I send the email? Shelley, SHELLEY at hofstech.com. I'll put that in the chat. That's my email. All right, so 3 down, 2 to go. Rolling for it. Nina, you have won a code. Yay. So just email me, and I will email you your code for free swag. All right, one more. I just like to choose random numbers, assign them to people. You are very welcome, Nina. Last one is Felix. You have won. Yay. I feel like Oprah when I do this. Like, you get a code and you get a code. Yeah. So that's all 5. So every session I host has free codes that I give away. So if you join anytime in person live, if you're watching this on YouTube, check out the group Docker Orlando. There is a link in the description. Oh yeah, and the last thing, I was asked to take a picture. Does anybody want to get on camera for that? So I can take a screenshot of this meeting.
I'll stay on camera. I'm okay.
Yeah. All right, we have a few people. Yeah. David, if you could stop sharing.
Oh, yeah, I was going to do that. Yes.
For just a sec. Yeah.
There you go.
Yeah.
That's it. Good.
Great. All righty. I'll try to get as many people on here as possible. All right. So we've got 2 of you. Divyani, very nice to actually see you.
Yeah, same here.
Yeah.
How are you doing?
Awesome.
Hi.
Good.
Hey.
Yeah.
Hi.
And we've got Karega. I think I have tried to pronounce your name before, and I hope that I did justice for that. Yeah. And we've also got Chukwemeka. I'm gonna get this, dude.
Chukwemeka.
Oh.
Chukwemeka.
Yeah.
Very cool. Very cool. And Felix, it's nice to see you as well. Nice to see your face.
Hello.
Hello. All right, cool. I'm gonna take a screenshot. Oh, but there you go. I was just gonna ask you. Can I call you Chuk?
Yeah, you can call me Chuk, or you can call me Peter.
I mean, do you like to be called Peter?
Sometimes, when people find it difficult to call the native names, just for easy conversation.
Yeah, but like, your name is important and people should pronounce it correctly. I think that's just me. Anyway, let us take this screenshot and get this show on the road. All right, I'm going to count and then take the screenshot. So smiles or poses or whatever. Okay? 3, 2, 1. Lovely. Very nice. Okay. All of us are smiling. All of our eyes are open. So I will post that on the socials. Yeah. Thank you very much for attending this last session of the year. I don't have any plans just yet for the next one, but you know me, I'll send them out when I get a speaker. So yeah, awesome. Well, happy holidays, and I hope you all have a great rest of the day and week.
Great meeting all of you. Thanks a lot.
Yeah.
Bye-bye.
Bye-bye.
Thanks.